All right, everybody, welcome. Thank you for coming to this 1 hour learning session for Tech by Choice. We had an idea just a couple days ago that it might be a fun opportunity to have a series once or twice weekly on Tuesdays and or Thursdays where we could bring somebody in to talk for an hour about something that they know a lot about and we can all benefit from it. So thank you to Amy for being the first person to do a speaking gig on this series. And if anybody else would like to speak, we are just collecting topics and people who might be able to join the series. Next week, we have a two-part on Tuesday and Thursday, building a website and deploying a website in under an hour. First session is going to be the HTML part, and the second session on Thursday is going to be the adding CSS and styling the website. So that'll be really, really fun. And then after that, we don't have anyone lined up yet. So if you'd like to speak, that would be amazing. And you don't have to have any speaking experience to be part of this series. So my name is Vanessa. I am the CTO of Tech by Choice. And I just wanted to do a really quick intro. Oh, Valerie's here. Hey, Valerie.
Hi, Valerie.
Valerie is our fearless leader, our executive director. I feel like I should put Valerie on the spot to do the intro.
I should have came on later.
Okay, just a couple things. So Code of Conduct, Tech by Choice is dedicated to providing a harassment-free experience for everyone, regardless of gender, gender identity and expression, sexual orientation, disability, physical appearance, body size, age, race, or religion. We do not tolerate harassment of participants in any form. If in any aspect of Tech by Choice, whether it be our Slack channel or one of these meetups, if anything makes you feel uncomfortable or unsafe or unwelcome, please let us know through any means, chat, email, and we will attend to that. We want everyone to feel like this is a safe space to learn without any judgment. I am a self-taught engineer. I started learning about 6 years ago. And if it weren't for open communities like this, where I didn't feel afraid to ask questions, I would have never gotten to where I am today. So we want to create that environment for all of you. So thank you very much. I'm going to hand this over to Amy. Thank you so much.
Thanks, Vanessa. Hi, I'm Amy Tobey. So if you do decide to present, this is part of my job now, is doing this stuff. So I put this one together 2 days, so I hope it's good. I would introduce myself more, but the whole talk is going to be kind of talking about my career and I'll talk about SRE on the way. So it's not all about me, but it's kind of all about me. And so to start with, I want to start with, Pong. I'm probably a little on the top side of the age range in tech these days. I'm in my 40s. I won't say where. But when I was a kid, one of the hot games was Pong, right? And Atari and stuff probably was more in my range when I was old enough to remember. But I remember one time I went dumpster diving, because that was a thing that we did when I was a kid, and I found a complete Pong system and brought it home, and it worked. And the thing I want y'all to think about as I talk about these concepts through this hour together is that Pong is this really simple game, right? If you dreamed of being a game programmer in the 1980s, the amount of stuff that you had to know to be able to build an effective and entertaining game was tiny. I mean, look at this game. There's squares and rectangles. Nobody has to do the area of a circle. Nobody has to do the volume of a bucket. None of that stuff. There's no like vertex calculations or shaders, all the stuff that we expect in games today. So while that game was implemented fully in hardware, the complexity of the game itself was very low. Simple rules, simple geometry, in a simpler time. So SRE, Site Reliability Engineering, is, for me and for many of the people in SRE, is really kind of a continuation of a profession called systems administration, which is where I started. I was a music major in Northern Michigan in the 90s. And That was going okay, but like I started to realize that maybe like being a band director wasn't really the right thing for me because I didn't have a lot of patience for kids at the time. And being a teacher in a school, it's kind of like the bar. So I had been playing, I'll come back to this. So I just wanted to give like, I'll bring this up later, but just an idea. So systems administration is kind of thinking about high availability, and I'll explain what that is in a moment. Operating systems, so Linux, OS 10, Windows, those are operating systems that take the hardware on your computer and take all the little differences that change over time. Like, you know, you're an Apple from 5 years ago and an Apple from today have very different hardware. But the programming interface that application developers use is still pretty much the same. It's changed a little, but largely the same applications work over time. And that's because the operating system takes care of that difference. You do a lot of scripting and automation in programming languages like Perl, Python, and Ruby at the time, and especially Bash, but I consider that part of the operating system really in the Unix world. You did monitoring, telemetry, logging, and alerting, which are kind of critical parts of being able to run applications at a certain scale. So monitoring says, is my service running? Is it doing what I expect it to? Usually I have simple binary yes, no answer. Telemetry is like, how much CPU am I using? Or how much of the network am I using? How much disk space is on the server? Logging is all of the stuff that your application prints out in the back end that goes into a file and has like these long lines of inscrutable text that tell you like what's happening in the application and especially errors. And then alerting comes off of those other things and says, okay, something has happened that the computers can't handle, and I need to tell a human so that so that I could come in and fix the computers. Then there was something called configuration management that's about abstracting away from editing computers directly, each one at a time, and being able to edit lots of computers at the same time, even if they have wildly different configurations on them. And system tuning, like making them go faster, making them run more efficiently, making them a little bit more reliable. So in site reliability engineering, and we're going to go over all this again, it becomes more, instead of scripting, software engineering. We're actually building large systems. We're building more software using the full software development lifecycle. We're scaling things out, both computers and people. So we might go from where, in my first job, I managed tens of computers, to today, where I manage hundreds and hundreds, or in some of my jobs where I manage thousands and thousands. So it's scaling out the computers and the networks and all the stuff that makes them go, but also like figuring out can one systems administrator, me, manage 1,000 computers? Can 10 people manage 1,000 computers? How do we make it so that 10 people can manage 10,000 computers? That's a big part of SRE. Incident management and analysis is a big part of it. I'll come back to that again too. And that's where basically like something broke in this big complex system, right? I used to work at Netflix, and I would get called and they would say, something's broken in Netflix. So there's a needle in a haystack. I would start an incident because often what it is we need to coordinate people from all across the organization. Sometimes I'd have to get programmers from different teams to talk to each other to figure out what was broken. And I'd have to go and talk to legal sometimes to make sure that our butts were covered on the legal front. Or I'd have to talk to corporate communications to say, hey, we need to push something out on the Twitter feed and out to our customers to say, we're working on this and we'll be back to you soon.
Yeah.
And then the analysis is afterward, going into what happened there and figuring out all of the things that contributed to making that situation happen and learning as much as possible so that we can build a stronger organization and make sure that the same things don't happen again, but also to make sure that people feel like that their needs were met and that the things were, that something is being done. And also really the core is the learning. Observability, which is much like those first things I mentioned, the monitoring, telemetry, and logging, but it's a little bit more. It has context that says in these big complex systems, and I'll show you a couple diagrams later, where you have tons of microservices and components spread all over a data center. And how do I say for this request that one person made from San Jose, California, and routed through the whole internet and came into my front end load balancer system and traversed all these services, and different things happen at each step along the way and sometimes branching out. How do I get all that into my head? It's so complex. And observability is about taking the abilities that systems administrators and SREs have to parse these big, huge systems and make it available to every developer. At least that's the way I describe it. Again, all of this stuff in this talk is Amy's view. And it may not be necessarily the mainstream view, but it's pretty close. Chaos engineering. Breaking things on purpose is the simple way to say it, although some of the chaos people would hate me for saying that. But it's setting up experiments, being scientific about it, and saying, I'm going to introduce this condition into my website or my database system and see what happens. But I'm going to do it with planning and methodology and with verification and control groups and all of those things of science, so that you can really draw solid conclusions from it about what is happening in your systems. And then process and product engineering is kind of like the big holy grail, I think, of SRE, which is in many, many production systems that you'll all see as you develop your careers. There's always kind of something that's broken. That's like the key feature of complex systems, right? Is there's always something broken. If you look around your life, right, look around your house, there's always something broken. On your car, something is always broken. But how do we create processes so that we can address those things, even things that aren't that big a deal, over time, so that we feed that back into the software engineering teams and the product teams and make sure that they're aware of it so that they can schedule work to be done to fix things, like calling your maintenance person, arranging for a time, getting them to show up, getting them to do it. Oh, they forgot the screwdriver, and now they'll be back next week. Like the same stuff happens in software engineering. And SRE, a big part of that is making sure that all the stuff that the end users never see, like the features and the shiny stuff, doesn't get dropped on the floor. So the stuff like, oh, this server is running a little slow. The end user of an iOS app isn't going to care about that. But me as the SRE, I have to care, because if you add up enough of those broken things, it turns into a crappy living situation. So my story. Like I said, I was a music major in the Midwest, in Central Michigan. And I was playing MUDs on the side, which could look kind of like this picture here. And so if you've played WoW or EverQuest or any of the modern MMOs, you've seen like the little text flow by of what's happening in the battles and chat and all of that stuff. This is where all that started. And so I really wanted to start modifying these games. And so I got the C Unleashed book. It was about that big, thick of a book. It was huge. I had no idea what was going on, but it gave me enough. I was able to start fiddling around in the code. And while my MUD didn't go anywhere, I did get connected to a lot of other MUD administrators. And I was complaining because I was using a compiler from a system called Cygwin, which was like a little version of Linux that sat on Windows 95. And it was terrible. It was slow. It was clunky. It broke all the time. And I was complaining about it, and they said, oh, here's what you should do. You should totally go down to the bookstore, totally, and pick up this book. I think that this is a later version of it, but Slackware Unleashed, which Slackware is kind of like the classic version of Linux. It was really kind of lightweight. They didn't have a lot of fancy features. There was a lot you had to do yourself. And so that's what I started with. I went through this book and I installed it on my computer. I screwed up the boot sector so it wouldn't boot anymore. And I spent about the next 6 months just kind of going through that book and learning Linux really well. While this is happening, I'm having that realization that I probably shouldn't work with kids. And I decided, hey, I'm going to start applying for jobs, because the boom was happening out in Silicon Valley. And tech companies or in the Midwest were hiring just about anybody who could spell FTP. So I had other privileges too, of course, but that's kind of the beginning, right? As I said, I'm going to start applying, and I did apply around and interviewed a few places, and finally I landed a job at a company called Oldie Discount, and that was my first job. Now this is not from there, but I was looking for an image that would remind me of the data center. So it used to be, we used to go, systems administrators would sit in the data center, and there was, like, you see those chairs, right? So it'd be people sitting in there with terminals in front of them, working on those computers, sitting in that cold, loud room, and being able to walk back and plug wires and move stuff around, right? That was systems administration at the time. And this picture really reminded me of it, and it's from NASA, so I can use it. You know, the room I remember is a little grungier. And I remember on my first day, or second day, the senior administrator walks by and is like, hey, Tobey, go log in the system, kill this process, and then the stock trading floor will come back online. So that's what was going on. It was 9:30 at a stock trading firm, and I go and I type a Linux command in and didn't realize it was Solaris. I typed kill all, which on Linux, you give it a name of a process and it kills just that process. But on the Solaris Unix operating system, it was literal. It killed everything. So that system went down, the phone rang, the, I get a stock trader, what the hell is going on down there? I didn't get fired. And I went on to do things there, like we had these systems called Stratus machines that were these like super highly available multi-processor machines that basically you could pull the motherboard out of live and it would keep going. But we had to hook that up to the NASDAQ, and we put a couple of Linux machines in between the NASDAQ network and these machines in high availability. So it was 2 machines so that we could run the same software on both. So if one died, the other one would take over. So that's kind of the beginning of high availability, right? And so this is a key skill to systems administration and SRE, is thinking really deeply about how do I make it so that if any one component fails anywhere in the system, usually, but often we have to focus on the things we can fix, right? So that if it fails, something else takes over or some other resource can pick up the slack, or at least so that the user knows for sure that they didn't do something wrong. So that's the beginning. And then I moved into the enterprise, but not this enterprise. I moved into this enterprise. This is just a random diagram I found on the web. And so we're already talking about this mounting complexity, right? In that first job, in the racks in front of me at my desk, there were about 15 computers. In this next job, in the data center I walked into, there were about 100 computers that had to be managed, right? And then not only were there 100 computers that were running all the healthcare management systems, but there were also these new things to me like SAN networks, right? And if you look at that where it says SAN down here, you see that there are these 2 brown boxes. Those are the SAN switching layer, right? So just like your router on your internet or your Wi-Fi, right? All the devices would connect to that, and then it would share the resource behind it, which is the disk arrays. And in the case of your Wi-Fi, the internet connection, right? So that everything can connect through it and get out to the outside world or get to the storage. These things were ridiculously complex. But the key feature there being that any one of these components could fail in here, and often the RAID, well, RAID itself means redundant array of independent drives or inexpensive drives. You'd have multiple drives carrying multiple copies of the data hooked up to these SANs, which had redundant switches so that you could turn one off and the other one would take over, connected 2 links to each server, right? So that each server could see through multiple paths, and then there was software to mediate that. So this complexity just keeps growing, right? But the goal is still to make it so that any single failure in the system doesn't take the whole healthcare system down for business, right? As time went on at that company, I worked on the SAN stuff quite a bit, did some really cool stuff there. And then later on, I started taking on the web farm, which was, they were one of the first companies to build an extensive website for various doctors and things to come and check and see what the healthcare company thought of a claim, right? It's probably not a good time to be talking about healthcare, but that's where I worked at the time. And so at the time we were in this kind of down here, this classic 3-tier architecture, right? So this bottom drum here is the database. We used Oracle at the time, but if you're working in the modern world, it's probably going to be like MySQL or Postgres. And there are myriad others like MongoDB and Cassandra and all kinds of stuff, right? So there's the database where all the data is stored, and then those purple orbs there would be the web servers, and those would run Linux, and those would run a web server called Apache, which is still around, but not as popular as it used to be. And then that would run Perl applications, which are just kind of like what most of us learn today. You write your HTML out and you print it to the page, and then you could do dynamic things by submitting back and forth. It was all kind of great. But the web developers were going so fast that they were driving me nuts. Because what they were doing is they were coming to me multiple times a day. Hey, can you roll the code out? Hey, can you roll the code out? Hey, can you roll the, because I used to have to roll the code out for them. And so we argued and argued, and finally me and one of the guys from that team sat down and we built some automation to say, okay, automatically take the code out of source control and run the tests on it, and then push it out to the servers. And just do it automatically. And then we ran it in every few minutes, we would run that script and it would check to see if there was new code and do the whole process and push it out. And then they stopped bugging me. Well, this is what we call DevOps today, right? So if you hear about DevOps, that's one part, but the really critical part that makes it DevOps is the part where me and that guy got together and talked about it and figured out a solution together, and then built the solution together, and then solved a huge business problem, which was that they wanted to go faster and I wanted it to do less work. And again, in all of this, while all this is happening, having to think about reliability, thinking about how to make it so that, thinking about all of the things that can go wrong, which I bet a lot of people in this room are good at already, right, is going into a situation and thinking, how can this go sideways? And that's a core skill for SREs. And then there's virtualization. And I already did a Star Trek image, so I thought of the Borg. I always think of the Borg when I think of virtualization. But we're going down that path some more, the mounting complexity, right? I'll talk about some more later, but like, I hope you're getting the idea that one of the key features of an SRE is, rather than being really deep in a single topic, like, you know, a great C++ programmer might know C++ inside out and backwards, know how to do bit flips in their heads, right? They know the hex codes for all the best colors. And that's what I would call a deep expertise. But what an SRE does, and I think more like what people call full stack developers have to do, is have a really wide experience of technologies and knowledge of lots and lots of different things. And so this new thing shows up around 2005, 2006 and starts taking off like gangbusters, called virtualization. So now instead of having a Linux server with a Linux, or a hardware server with a Linux operating system running a web server, now we put that additional layer in there of the hypervisor. Sorry, can you please mute, Kanan, I think?
My apologies.
No worries. So now we added this virtualization layer, which is a whole nother operating system, really. It's a small operating system, ideally, but we've just like increased it in order of magnitude and complexity. And this was happening about the time I was moving out of that job into my next job, where I did more of it. Around 2007, I was kind of getting tired of Michigan and working at a healthcare company. I really wanted to do more hard tech. And so I started applying around stuff on the West Coast. And the one I ended up selecting was Sony Online Entertainment. And going back to my MUD roots, right? Like working on MUDs, but now I'm working on the servers that run these games like EverQuest 2. And just to kind of give I hope this image just kind of gives the hop in complexity that I was talking about, right? So we started with Pong, you know, and maybe Atari or NES and SNES. And now we're at this EverQuest 2, which is very much a similar game to the kind of games I was playing back then, but now there's graphics, right? There's round stuff. There's many people on the same screen. There's shader effects. You know, you see the glowing stuff around the arms of that with under the star there in the middle here. There's just all this complexity going on in the client, and then that's talking back to a server, which is now talking to hundreds of other clients. And so this is the place where I really started to learn how to manage thousands of machines as opposed to maybe tens or hundreds. The other thing I kind of picked up at SOE was they had some systems that are way ahead of their time. They're still ahead of the time we're in now in some ways. They had observability as opposed to telemetry, so that you could see the flow of events through the system, right? And I wish I could find screenshots of it, but unfortunately there aren't many around. And then it had that automatic deploy system already when I got there. So I was a Unix administrator. I kind of kept the servers all updated and then started to implement some stuff to make them easier to install and all that. I went to Cisco for a while, for a year exactly. I was so bored. I ended up making a tiny version of Docker right about the time Docker came out, and then kind of threw it away because Docker was easier. But then again, Docker comes along, right? And now we've got containers, and containers sit on virtualization, which sits on operating systems, which sits on hardware. And we just keep adding layers to this stack, right? And as an SRE or a full stack developer, your job is to be able to think through the whole stack, right? Moving forward, I was at Uyala for a couple of years, which is a white box video company. Think of it like YouTube for people who don't want to use YouTube because they don't want to have the YouTube logo. But it gives you all the like analytics and stuff. So I own the big data platform. So I had to learn Hadoop, and I had to learn how to tune JVMs and run Cassandra. So like this is the other thing, like going wider, picking up more databases, and really starting to get my head around distributed systems. Which is if we were in a big room, I would say who's heard of distributed systems. We don't need to do that right now, but basically the idea being that anytime you have two major components, right? You have components that are spread out widely that interact with each other, create these complex systems where they have things like a transaction where you have like a bit of information you get from a user and you do something with it here, and then you pass it over here and it does something, and you pass it over here and it does something, and it passes it back over here. That's a distributed system, in a very, very simplistic explanation. And even the diagram I'm showing you is a distributed system, right? It's many large complex systems interacting all together. And the kinds of weird crap that can happen when you have this much complexity in a real world scenario under load with random data coming through, good data, bad data, huge data, small data, all that. And then there's just I mean, think about all of the weird little glitches and annoying things that your computer or your phone do today, right? And then multiply that times 5,000 when you have 5,000 systems. And it's just about that bad, right? And it's just random crap just breaks, right? There's always something to do. There's always something broken. So it's another like one of those skills of an SRE is to think in these distributed system terms, to understand that the system is always degraded. It's always a little bit on fire. And then thinking about prioritizing, being like, which fire do I put out first? I went from Uyala, I went to DataStax for a little while, which is a company where I did developer relations for a database, the distributed database. I'm not going to talk about that one too much. I did learn a lot there, but it wasn't SRE stuff necessarily. And then I went to Netflix, where I was an SRE. And this is probably the highest level SRE role I've worked at, in that at Netflix, the SREs, at least the team I was on called Core SRE, got paged when streams per second went outside of prediction. So what I'm saying is like, think about what's going on right now. Everybody's at home watching Netflix, right? And so every person that pushes play on a video, it causes a bunch of stuff to happen in Netflix. The diagram I'm showing you is an older diagram with all the labels removed of what Netflix's architecture looked at the time, right? And so that front one on the far left right here, you can see my mouse cursor, right? I hope.
Yes.
Was like the load balancer where the traffic first came in, right? And then that would split requests off and it would splatter all over the place to all these different services. Are you logged in? Does that movie exist? Is it available in your region? What copy protection does it have? Oh, hey, we should save the fact that this happened. Just so much stuff happening. We would get paged and it would just say something's broken, right? Like people are unable to start movies. That was the biggest emergency that we had to work on. And so we had to go into this huge complex system and figure out who to call, what was broken, and trace all that down. So it's bringing all those skills I've talked about leading up to here together, right? Be able to understand a graph, right? So if I draw a graph with a jagged line, what does it mean if it's going like this versus if it's going like this, right? So it's understanding like at that very zoomed out level that you can see here, when a request hits that first node and then fails to get to the second one, right? The first circle to the second one, why might that happen? And being able to imagine the different kinds of scenarios and quickly test those hypotheses. So we would do that, but we would also have to do incident management, which is saying, like, I can't solve this problem myself. This system is way too big for one person to fit in their head, let alone be able to actually fix it and also fix it in the amount of time that makes sense for Netflix. If people aren't able to play Netflix videos today, we might have some big problems out in the real world, right? When people get so bored that they leave their homes or cause problems, right? I'm exaggerating a little bit, but the idea is to get across is the pressure. We had 5 to 10 minutes to figure out what the heck was going on and start calling in developers to fix the issue as quickly as possible. So incident command is basically making sure that all those people come together, that they work together, that they all understand the problem in the same way, that they're sharing information with each other, talking with people like corporate communications and making sure that the people out in the world that want to know what's going on with Netflix understand what's going on, because I ain't talking to the press. And so that's incident command is really, that's what it's about, is keeping that cohesion through a very stressful time. And then afterwards, taking all the stuff that we learned from that, capturing it, and turning it into something that we can use to make the system better, right? To learn, to teach people things like, hey, don't do that. We learned from this incident that was a bad idea. Or, just, we probably need to go look at this system over here because it caused this problem and it probably needs some love. So that's just kind of a quick overview of incident analysis and incident command. Those are a big part of what people talk about as SRE today. So if you ask the random people, ask 10 people what SRE is, you're getting 11 answers, and probably 11 of those answers will include incident command and incident analysis in it, because that's a big part of SRE. After that, I did get fired from Netflix for good reasons. There was a lot going on at the time. And I moved on, and I moved around a bunch afterwards. So I spent some time at Apple, and I spent some time at Tenable and GitHub, where I did similar things, and at Elastic. And I kind of bundle these all together because kind of that's where during that time is when I formed this idea that really SRE does include systems administration, because there's a big argument out there about SRE that says really SRE is these things like incident management and SLOs. I'll talk about that in a minute. And in these kind of higher level functions. But really it does still in software engineering, but really it does still include a lot of those systems administration tasks. Most of the people I've worked with over the years, the vast majority, are systems administrators and also SREs, instead of being like pure SREs, if there is such a thing. And so now I'm at Blameless. You've seen all over my slides and stuff. And the company I'm at now, like, they pay me to do this, to talk to people about SRE. And we make tools for helping SREs. And so this is a topic that's very near and dear to my heart. I won't spend a lot of time on it. But to say that there are kind of these branches that come off of SRE. Very often SREs branch out into different roles. A lot have gone into what's called developer relations, which is a role where you do this. You get out, you do talks, you work with people one-on-one and help them to learn technology and skills. You work with product teams to help them understand what people are seeing in the field. There's a lot of different flavors of DevRel, but that's a branch I've seen a few SREs go off into. A lot have gone off into software engineering. I've done my own stints in software engineering. So it's an interesting, because you've got this wide experience of technologies and philosophies, and really kind of honing your gut around how things fail and how to figure out what's broken about them, right? So, if you've ever heard the story about, your great grandpa or whatever that could walk up to a car and, sniff the oil and go, "Ooh, I know what's wrong with that car," right? That's the kind of thing you build up over time, is that sense of what's going on here from very little information. And being an SRE is about taking that skill and making it available to the wider organization. So back to this list. We have systems administration, which, high availability, which tends to focus on a narrow silo within the system to say, how do we cross-connect things and have redundant systems such that a single failure doesn't take the whole system down? You have operating systems down at the bottom, running Linux, and I'd probably include virtualization in that. You have scripting to kind of make sure that things happen in a certain order, and that if you reboot a machine, it starts everything up. There are regular jobs running on a clock timer called cron that, clean up old disk files, or, just do random things that need to be done to steward the machines. Configuration management to scale that all out to many more servers. And then kind of system tuning, like, making little tweaks over time to make the system run a little bit better. And often that's focused on performance, making the response time for a user just a little bit faster, and then a little bit faster, or making the software so you can buy less computers sometimes. And then we add an SRE. And so for SRE, we kind of think, instead of scripting, right? So when I was a systems administrator, I could just write a script and put it on a production server and walk away, right? I would test it kind of in production. I would make my changes and just kind of live edit, and then I would later check it into source control. These days, we tend to do things in SRE more the software engineering way, right? We plan our work ahead of time. We write our code in such a way that it can be tested and broken down into modules and managed over time, and then rolled out in reasonable ways so that we don't cause production outages. So that's what I mean when I say software engineering and testing. Is an SRE really does have to have maybe not the same depth of that skill as somebody who spends every day writing code, but has to understand the whole life cycle, the processes, especially like things like Scrum and Agile and stuff like that, because we have to use those, because we also, if we get down to the bottom of this list, need to understand those so that we can help feed work into that system to help make systems more reliable. Scaling, like I mentioned before, not only scaling to tens or hundreds of servers, but to thousands and tens of thousands. And I have friends at Google that would hit 10,000 or 100,000 servers with a service. And then also, like, once you get to that many computers, you're also talking about large software engineering teams, release teams, product management teams, tens or hundreds of people working together on the same system to make it, to add features and to kind of keep moving forward and growing the business. But the SRE is the group of people sitting there saying, okay, yeah, that's all great, but we also have to continue making the system reliable as we do that, right? So we can't just kick software out the door. We need to test it. We can't just kick software out the door. It has to have all of these things like telemetry and logging, observability, right? And often we end up owning those systems, the back-end systems for those. So, if we deploy observability, probably the SRE team owns the contact with, if you use an observability tool like Honeycomb or Lightstep, or there are others, like New Relic. The SRE team will be the one that starts that and kind of pushes it forward and owns that relationship with the company over time. Or if they're using something like a Prometheus or some of the open source observability tools, they would run those backend systems. So they tend to own some like smaller back office kind of things. Chaos engineering is kind of, everybody gets excited about that because, yeah, I get to break stuff, except it's really about science. And once you get, the thing about science is super exciting when you're thinking about being a supervillain. And when you're doing like really rigorous experiments, it starts to become a little bit more humdrum and very business-like, because you have to have control groups, and you have to design your experiments up front, and you have to account for all the different things that can contribute to variability in your measurements. And so that's what chaos engineering is being a scientist of failure and success inside of your system. And then finally, where most of my passion is these days is the process and product engineering part of site reliability engineering. So there's a concept called SLOs, which is service level objectives, which is a way of saying, I'm going to set a metric based on what the user sees, right? So I've got a web service that you go to, and it serves you a web page. What I would measure is like, how long did it take me to serve you that web page, and was it successful? Those would be my SLIs, so service level indicator. That's all basically still monitoring at this point, right? But what the service level objective adds is it says we also have an error budget. So we know we can't be perfect all the time. 100%, if you remember nothing else from this talk, 100% uptime is impossible, absolutely impossible, right? We talk about nines, so 99.99%, or we'll say 5 nines, 99.999% available, right? And so an SLO says, you know what, I'm going to measure that last 0.001% and let people burn that. So if you push lots of features and you're not actually taking downtime, then you can just keep pushing features. But if you're pushing features and you're burning up that remaining time we have to be down and still meet our agreements with our customers, then we got to have a business discussion, right? To say, do we start to pull back the number of features we push out and start pushing out more reliability work, right? Going in and fixing all the like to-dos and the what we call tech debt in the code. And so that's what I mean when I say process and product engineering. Is SLOs is really about building the process and the life cycle inside of an organization that says we recognize that things break out there and that the business probably largely doesn't care about the stuff that customers don't see, which is the stuff that SREs deal with every day and systems administrators and a lot of coders deal with every day, right? But we have a hard time getting it prioritized. And so these are setting up systems to make the system healthier by feeding that work when something breaks, figuring out what broke, feeding it back into the product life cycle and getting it worked on alongside the features. And SLOs are a popular way to create that system and represent it and measure it over time. So that's my whirlwind tour of what it is to be an SRE. If you have any questions, please put them in the chat. And thanks for listening.
Wow, that was so cool. Thank you so much, Amy. Yeah, so if anyone has any questions, yeah, put them in the chat and then I'll relay them. So Amy, JC says, thanks for including a narrative about your journey. That part is really helpful. Can you say more about what it took for you to stay in the field in terms of finding a comfortable space and in terms of professional development?
Oh gosh, good question. I think it's fairly obvious that I'm not a terribly conformist person. And so it's been a struggle for most of my career. And so that's why I feel that that's a really strong question is one of the things and one of the reasons why I love presenting this to this group is the systems administration field and really, or web operations is kind of a broader term for all of this stuff. At least back in the early 2000s, was a place where I worked with so many high school dropouts, college dropouts, philosophy majors, musicians still to this day, they're everywhere in this field. And because you can start on some small part, like remember I talked about I'd sit in a chair and type commands, and often those commands were printed on a piece of paper right here. Like you didn't have to know that much. You just had to do the thing, right? So you would start there and then you'd get annoyed and you'd start building scripts to automate it because you make it more efficient. And then your boss would notice, be like, oh, hey, I'm going to promote you and have you do more of that. It was the entry point. But what really kept me going is this community of misfits, right? And that's what I love about operations is there are so many misfits. I think that helped a ton. Now I'm at Silicon Valley. It's a little bit more homogenous than it used to be. Or at least my experience was. But I think that's really kind of what it was. And I had a lot of help along the way. I had a lot of good mentors. I had a lot, like that first big job I talked about at Priority Health. I was there for 7 years. That was a really forward-looking company. I mean, it was 60-something% women, which I have not been above that number since. You know, and it just had a culture of allowing people to explore, and we were trying things. Nobody told us not to do it. Like when we built that deploy system, we just put it out there. And so those opportunities are a little harder to find today, but they're a little easier to find in web operations than they are, say, in software engineering. So you drop into software engineering, everybody wants you to be doing React and full Node.js and JavaScript, full stack, CSS, this amazing amount of complexity right on day one, right? Whereas, you know, finding that spot where you can start and really build some expertise around one part of the system and work your way up and kind of spider out through the different subject areas, I think is the way that I grew. Is I just kind of followed my interest and got very, very, very lucky and privileged that I was able to keep following my nose. And, oh, thank you, Luna, yeah, for staying up. I think they, okay. Any more questions? Okay, junior, what's the suggested path to SRE and chaos from junior lip? Okay, so if you're early or mid-level software engineer and you want to head toward SRE, The first thing to do is to make friends with the closest SREs you can find. Most SREs are looking for developers who will both listen and help, right? So we're constantly, we have this big list of things that need to be fixed in the system, right? If you can be a champion of taking care of all of the stuff that doesn't get done, right? If you've written code, you've done it, right? You've written to do, make this not be stupid, right? To do, add error handling here. To do, make this so it doesn't crash when the one person clicks on that one button, but it doesn't happen that often, so no big deal, we'll do it later, right? Is start working on that stuff. Start figuring out how to get airtime for it. The other one is to dig into the operating system. Start to understand those low-level interfaces. Now, back in the day, I would say probably Linux was where you wanted to be. Today, it's probably starting to build your expertise around containers, maybe starting to branch into Kubernetes, because that's the tech side, right? And that can lead you into roles where you're working on that, but start to have access to things like doing incident management, because you'll be down at the bottom of the system where all the really, software fails out here, and somebody goes, not my problem, not my problem, not problem. Guess where the buck stops? Right here. And so if you get over there into the infrastructure space, working on something like a Kubernetes cluster, or working on AWS orchestration with a tool like Terraform, those are great opportunities to start to pick that up. And there's almost always a demand for that work at almost any org I've worked at. And we have from Luna. Have I had pushback from colleagues or leadership when trying to introduce reliability topics? Heck yeah. And in the context of your jobs where your position was not SRE, did you have any tips to deal with those? So I just talked about that a little bit. So I absolutely, even today, working at a company where we do SRE stuff, because I still get that pushback, but it's for good reasons. I think that's the main thing to keep in mind, right? Everybody, most of the time, people are trying to do their best, right? There are occasionally like nefarious jerks, right? We've all run into them. They're pretty obvious, but most people are trying to do the best with what they have. So the product person who is obsessed with features, and they go, you know what, damn the torpedoes, we're going to ship this feature and that feature and that feature, and we're not doing any of that backlog work for fixing stuff up because the customers don't care. The customer only cares about new features, right? That world is changing though. So I will get that pushback when I say, hey, you got to ship one less feature because I need you to fix this other problem over here, right? The solution is usually to start talking with those people more deeply about, so do our customers care about reliability, right? Because most of the time it just takes a little bit more like empathy and talking and to get those thought processes going in other people's heads, right? This is the whole job a lot of times, is saying, if our website is offline, does that feature really matter, right? So you added the new whiz-bang thing, and it makes, like Amy's image on Zoom has like little sparkles coming up like this, and she's always dreamed of that. We have to ship it, right? But if Zoom is unavailable, does it really matter even a little bit? It doesn't, right? So reliability is a super important feature. And back in the day, go back to the 2000s or even just a few years ago, and like when we would see the Twitter fail whale all the time, or Facebook would flake out every once in a while, or even Netflix used to fail a little bit more, right? That's not acceptable anymore, right? Today, if Netflix failed today, like that, it would be all over the news. It would be a headline on CNN. It would be all over Twitter, right? And that's why Netflix invests so deeply in their reliability, is because they know that. And even for your smaller services, like a little service I work at now, reliability is a core feature of our product. And so I don't have to have as hard of a fight here as I have in other jobs, but that's really the fight, or the initiative to take forward, is to convince people that reliability is an indispensable feature of their products. And that's the next question. So if there are no more. Awesome. Well, thank you for listening, everyone. It was my pleasure.
Thank you, everyone.
And be safe out there.
Yeah. All right, we'll be posting this on the website tonight, and I'll share the link in Slack. If everyone hasn't signed up for Slack, I'll post a link to do so in the chat right now. One second, sorry. Oops. There we go. All right. Thank you so much, Amy.
My pleasure.
Bye, everyone.